fear from exam.
Topics to be covered in this lesson are introduction, powers with negative exponents, expanding decimal numbers, laws of exponents, smaller numbers in standard form, comparing very large and very small numbers. Let's say if I ask you, how far is your school from your home? So the distance between your home and your school might be a smaller number, maybe somewhere around 15 kilometers, even if we consider that the school is not very near to your place. So 15 is not a very big number, so it can be very conveniently represented like this, 15 kilometers. Now if we ask you the distance between your city and another city, so let's say the distance between Bangalore and Delhi. So if you compare the distance between these two cities, the number increases. So it might be somewhere around 1700 kilometers. So again, 1700 is definitely a bigger number than 15, but still it is like quite okay to be conveniently represented. So this is also fine. Now if I ask you what is the distance between your country and let's say any other country, for example, we say distance between India and South America. So if you talk about this distance, it might be somewhere around 14,953 kilometers. So you see, gradually as the distance is increasing, the numbers are also increasing. Now if I ask you the distance between your planet and the sun, so distance between Earth and sun, what's that distance? So it is somewhere around 150 million kilometers. Right? So when you look at these numbers, what do you see? First you talk about 15, then we spoke about 1700, then we spoke about 15,000, and then we spoke about 150 millions. So what happens as the number increases, we see that it becomes very difficult to represent big numbers. Like if I ask you to represent 150 million kilometers in figures, in numbers, how would you represent? You need to write 15 followed by 7 zeros. So that's not a very convenient representation. Now you can even have numbers as big as maybe 150 followed by 15 zeros or 17 zeros or even 20 zeros. So what do we do to kind of handle these kind of scenarios? So the concept of exponents, the concept of powers makes the representation of bigger numbers easier. Now when I say bigger numbers, not only the bigger numbers, even the smaller numbers. For example, so these are all examples which are given to show the bigger distances. Now if we talk about smaller sizes, for example, if I ask you the size of a cell is very tiny, it's microscopic. You talk about the size of an electron, it is again very small. So for very large numbers or very small numbers, the representation becomes easier with powers. Now let's see that how exponent helps. Now let's say that we have a number, let's consider 100. So how can we write 100? So 100 can be very well written as 10 multiplied by 10. We can write it like this. Okay, perfect. Now this can be written as 10 to the power 2. What does this mean? This means that 10 is multiplied 2 times. So 10 to the power 2 is that's what it means. Now you might say that okay, but writing 10 into 10 and 10 to the power 2 both are equally convenient. So why do we need to the power 2? Well, in this case, it might sound like this didn't bring much difference, the concept of power. But as you move on to bigger numbers, for example, you talk about 1000. So then it becomes 10 into 10 into 10. So 1000 is 10 to the power 3. If you talk about 10,000, that becomes 10 into 10 into 10 into 10. That is 10 to the power 4. Now in similar way, if you talk about a number which has maybe 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 zeros. So that number can be very well written as 10 to the power 10. Now you tell me which is more convenient, writing this or writing this. So definitely writing this is more convenient. So you see, that these are kind of easier representation of numbers. So especially when we deal with very big numbers or with very small numbers. So this type of representation is called the exponential form of representation. So these are called exponential form. So when you write any number to the power some other number, so that representation is exponential form. And how do we read this? We read this as 10 to the power 2, 10 to the power 3, 10 to the power 10, and so on.